Welcome to all to the video session. I am the maths faculty in Vidya Lakshmi, NEET and JEE Academy. Now today I am going to take in the CBSE 11th 12th standard TERM-1 portion in this relation and functions part 2. First part already covered, the second part we are going to take this class. Okay, now going for the first problem. Come here. Look here boys, this is the first problem. It's from n to n given by f of x equal to x plus 1 if x is odd, f of x equal to x minus 1 if x is even. What about is a 1 1 or on 2? Okay, look here, the function is given by f of x which is equal to x plus 1 if x is odd, x minus 1 if x is even. We want to check it is a 1 1 on 2. You know that what is the definition of 1 1? Already we discussed in the first part. Now look here, I am taking the case 1. What is the case 1? Both x and y are x and y are even. Second case, x and y are odd numbers. And third case, x is even and y is odd. We split the problem in the three types. Both number x and y are even and another one odd and another one is a even, another one is a odd. We have to check the condition of x not equal to y implies f of x is not equal to f of y. Let us check. Look here, I am taking x is not equal to y, the two numbers from the domain. This implies x minus 1 also not equal to y minus 1. This implies f of x is not equal to f of y. This is the required condition for in the case of even, x comma y even implies x is not equal to y. The corresponding images are also different. Now, x and y are odd. Then the x and y are different, which implies the corresponding x plus 1 is not equal to y plus 1. This is also clear. So automatically this implies f of x is not equal to f of y. This also satisfies the 1 1 condition. The first case, both x and y are even. Second case, both x and y are odd. And another one, x is a even and y is a odd. Now, x is they are different. X is not equal to y implies x minus 1 is also not equal to y plus 1. This implies f of x is not equal to f of y. Now we are taking the three cases. We are taking the two elements from the domain x, y. First case, even. Second case, both are odd. Third case, one is even, another one is odd. In all the checking, x is not equal to y, f of x is not equal to f of y. This shows that x is not equal to y implies f of x is not equal to f of y. It is f is 1 1. F is 1 1. The question is, check it is a 1 1 or not. Now, the three cases we have to taken all the cases the condition is satisfied. Therefore, in general, x not equal to y implies f of x is not equal to f of y, f is 1, 1. The first part is over. Second part, on 2. For the on 2, what we are going to do? Second part, f is on 2. We are taking some elements from the codomain. The domain, it means that both, I am taking a even number. That is, the y belongs to the codomain of the function. Then f of, it may be a even number. It is a even. Therefore, there x is a x. There x is an odd number in the domain of the function such that f of x equal to the even number y. For whatever the even number in the codomain, we can find a odd number. In this case, it is equal to f of x equal to y. Similarly, there x is a y belongs to the codomain of the function. It must be an odd number. Then there x is a even number belongs to the domain of the function such that f of x equal to y. Therefore, in the codomain, if you take an even number, then corresponding pre-image equal to odd number. In the codomain, it is a odd even number. The corresponding pre-image is a odd, even means odd. Therefore, totally I am concluding that f of odd, it gives a even number. F of even, it gives an odd number. Therefore, the n consists of either even or odd. Odd numbers are going to the pre-images of even number, and even numbers are the pre-images of odd number. That is the case. Therefore, f is on 2. The first case, f is 1, 1, and second case, f is on 2. F is on 2. Handwriting not good. F is on 2. And conclusion, F is a 1, 1, F is on 2. This is a problem we have to solving by the formal method. Now, what is the problem? It is a MCQ question. The MCQ question, we have to solve the problem in the fraction of second. It means 1.5 minutes. At the maximum 1.5 minutes. So, you should not choose this method. You must know the method, but you have to take the result, take it granted. And so, what I am doing, I am clear the board. The result is f is 1, 1 on 2. So, this must be keep in mind. You should not solve the problem. You must know the problem, how to solve it. That is the answer. F is a 1, 1 on 2. Here the four options are, not 1, 1, it is not correct, not on 2, not correct, 1, 1. Therefore, the C is the correct answer. For this problem, C is the correct answer. This problem is a big question. We are solving, it takes minimum 3 minutes. If you solve this method in a MCQ question, it will take another problem also, waste of time. So, use the shortcut method. That is, the result should be taken in granted in your mind. F is 1, 1 on 2. I am checking that it's not true, it's a correct one. Therefore, hereafter, whenever this type of problem is coming, you have to keep in mind that it is a 1, 1 on 2 and use the result. Now, I am going for the second one. The second one equal to the f from r minus 0 to r defined by the function 1 minus x. The question is a 1, 1, many 1 into none of this. Now, I am going to check 1, 1. Look here, f of x is given by 1 minus 1 by x. In order to check 1, 1, I am taking two elements from the domain. X is not equal to y. I am taking two elements from the domain. This implies minus 1 by x is also not equal to minus 1 by y. This implies 1 minus 1 by x is also not equal to minus 1 by y. This implies f of x is not equal to f of y. Therefore, it is true for all elements belong the domain. X not equal to y implies 1 minus 1 by x not equal to minus 1 by y. It's always true. Then 1 minus 1 by x is not equal to 1 minus 1 by, I am adding 1 for the both side. Then result never change. This means f of x, this means f of y. That is, x not equal to y implies f of x is not equal to f of y. Therefore, this f is 1, 1. F is 1, 1. The first part is over. What about on 2? On 2, let us check it. For on 2, we have to find the inverse function. Y equal to, for on 2, y equal to f of x, which is equal to 1 minus 1 by x. Therefore, 1 by x equal to 1 minus y, which is equal to x equal to 1 divided by 1 minus y. Then, for every y belongs to, this is equal to f inverse of x equal to 1 by 1 minus x. What are the value for this? The x is not equal to 1. X is not equal to 1. For the range of the function, x not equal to 1. F of 1 equal to, what is the value? F of 1 equal to 0. Therefore, look here, some problem is coming here. Y equal to f of x equal to 1 minus 1 by x. That is 1 by x equal to 1 minus y. I am interchanging these two. X equal to 1 by 1 minus y. That means f inverse of x equal to 1 by 1 minus of x. What are the range for this? The range of the function f inverse, range of the function, the range of the function f inverse, which is equal to the set of all r minus 1. The minus 1 should not have the pre-image. Let us check how it's working or not. Minus 1 should not have the pre-image. Yeah, well, if I put 1 here, 1, that is, look here, I am checking, f of x equal to 1, which is equal to 1 minus 1 by x, the value, this implies that is, look here, f of x, y equal to f of x, this value equal to 1 minus 1 by x. Therefore, 1 by x equal to y, x equal to 1 by x equal to, sorry, 1 minus 1 by x, small mistake is there, we will correct it. Y equal to 1 minus 1 by x. Therefore, 1 by x equal to 1 minus y. Inverted it, 1 by 1 minus y, which is equal to f inverse of x. F inverse of x equal to 1 by x. The range of the function equal to f inverse, which the range of the function which is equal to a set of all r minus 1. Therefore, 1 should be removed from here, but it is available. What is the image for 1? Let us check. 1 should not have the pre-image. That is, f of x equal to 1. Then, 1 minus 1 by x equal to 1, which implies 1 by x equal to 0. This implies x equal to 0. X equal to 0. It is not possible. 0 is excluding. Therefore, this shows that this implies that is 1 belongs to the codomain, no pre-image. No pre-image. Therefore, is not on 2. Therefore, the f is not on 2. This function is a 1, 1, but not on 2. What is the reason? Already we proved it is a 1, 1. Now, what happened? The 1 belongs to the codomain that has a no pre-image in here. Therefore, it's not be a onto function. The answer is 1, 1, many 1 into the correct one equal to first one. Correct one equal to first one, 1, 1. The function is 1, 1, but not on 2. Okay, let's go to the next one. The next function is next problem is very simple. The number of functions can be drawn from A to B. Very simple, number of functions. Number of functions from capital A to B. It is the formula order of B whole power order of A, which is equal to order of B equal to 3 and order of A equal to 2. The answer equal to 9. 9 functions can be drawn from A to B. A is a set and B is another set. From A to B, how many functions can be drawn from A to B? A consists of 2 elements and B consists of 3 elements. From here to here, how many functions we can draw? With the formula equal to order of B whole power order of A 3 power 2, which is equal to 9. 9 functions can be drawn from A to B. The first one is a correct answer. The answer equal to A. B, C, D should not be allowed. It should be removed. Now go for the fourth one. Fourth problem, domain of the function. It is a very simple. Look here. The log x function is, we know that the function it starts from here, it's coming here. This is a point 1, 0, which is equal to y equal to log x to the base e. In the problem, the log x function takes the value from 0 to infinity and 0 should not be allowed. But another method, y equal to log x, the function is defined if x greater than 0. That is the domain of the function equal to 0 to infinity. 0 to infinity, here also from here to here it takes all values. Therefore, the domain of the function equal to 0 to infinity. The first one is a correct answer. Remaining B, C, D are not necessary. Leave it. Now go for fifth problem. The fifth problem, domain of the function root x. F of x equal to given by the root x. Root x, what are the values given the root x? Negative should not be allowed. Only positive. Therefore, the x should be greater than or equal to 0. This implies domain of the function equal to the closed interval 0 to infinity. Closed interval 0 to infinity, the answer equal to, look here, the answer equal to C. The answer equal to C, A, B, D should not be allowed. The correct answer equal to C. I am giving additional problem here. You see that, suppose f of x is an additional problem. F of x equal to 1 by root x. What is the domain of the function? The two functions are same, but one is the numerator, another one is the denominator. In this case, denominator 0 should not be allowed. Therefore, inside the root expression, x greater than 0 only. Therefore, the domain of the function equal to open interval 0 to infinity. You see that the same function f of x equal to root x. I am changing f of x equal to 1 by root x. If the root x in the numerator, the inside the root, the x must be greater than or equal to 0. The domain of the function equal to closed interval 0 to infinity. Suppose the function is 1 by root x, denominator should not be 0. I am excluding 0. That's x greater than 0. Domain of the function equal to open interval 0 to infinity. That is a small difference. Even though additionally I am giving the point. I am going for the sixth one. Sixth one, the function from the domain to R defined by this one. Find the range of the function. The range of the function, in order to find the range of the function, you must know the inverse of the function. For this, I am taking, find the inverse of the function. The first question, f inverse of x. For this, y equal to f of x. Y equal to f of x, which is equal to 1 by x squared minus 4. Cross multiplying, x squared minus 4 equal to 1 by y. Then x squared equal to 1 by y plus 4. On simplification, 1 plus 4y divided by y, which is equal to x squared. Then x equal to plus or minus, you are taking the plus only, the 4y divided by y. That is f inverse of x, which is equal to square root of 1 plus 4x divided by x. It is a routine procedure. You know that how to find the f inverse of a function. The function is given by f of x equal to 1 by x squared minus 4. That is the routine procedure. You know everything about F inverse. That's why I am giving high speed. The F inverse of x equal to this value. Now, the range of the function equal to range of the function f equal to domain of the f inverse. It is a correlation. In order to find the range of the function which is equal to domain of the f inverse. Domain of the f inverse means what are the input value for the function. What are the input value for the function? Inside the square root, that must be the expression should be greater than or equal to 0. The inside the term should be greater than or equal to 0. For this, look here. I am 1 second. Clear the board. Now the function f inverse of x equal to square root of 1 plus 4x divided by x. What are the input value? We know that already discussed the same case. 4x divided by x, it must be greater than or equal to 0. Equal to symbol should be implied. Now, how to find the value? I am multiply the denominator to the numerator both sides. Multiply the denominator x term, numerator and denominator. Therefore, it gets x into 1 plus 4x divided by x squared greater than or equal to 0. This implies x into 1 plus 4x greater than or equal to 0. I am rewriting this. I am rewriting x minus 0 into x plus 1 by 4. It's a greater than or equal to 0. X minus 0 into x plus 1 by 4 equal to 0. It is x minus 0 into x minus 1 by 4. We have a one result we are going to use. What is the result? X minus alpha into x minus beta is greater than or equal to 0. Provided alpha less than or equal to beta, then the domain of the function equal to minus infinity to alpha union beta to infinity. That is the result I am going to use. X minus 0 into x minus of 1 by 4 greater than or equal to 0. Therefore, the domain of the function equal to mark the point minus 1 by 4 and 0. This side, that is this side the domain of the function. That is the domain of the function of f inverse which is equal to therefore the domain of the function equal to minus infinity to minus 1 by 4 closed interval or open interval. Here equality is given, therefore it is a closed interval. This also closed interval. I am small change, giving a small change. Now it is a closed interval union 0 to infinity. It is the domain of the function. Domain of f inverse. Domain of f inverse means automatically what is that? It is the range of the function. So, in order to find the range of the function, I am starting with the y equal to f of x. Y equal to f of x and simplify f inverse of x I find. Upon that, what are the input value for the inverse function? It gives this much. From this I am interpreting the result which is equal to minus infinity to minus 1 by 4 union 0 to infinity. Here the correct answer equal to, this is not the correct answer. This is also not correct answer. This is also. So among the 4 options A, B, C, D not correct. Therefore none of them is the correct one. Fourth one is the correct. Before that I am giving one result. I have to recall it for you. That is, in the problem I am using x minus alpha into x minus beta, where alpha less than beta is greater than or equal to 0. Then the domain of the function equal to minus infinity to alpha and closed interval union closed interval beta to infinity. That is the domain of the function. This result I am using. If you know the result only, you can write the answer immediately. Otherwise, not possible. Similarly, one more result is there. The one more result, x minus alpha into x minus beta is less than or equal to 0. Then the domain of the function equal to the closed interval alpha to beta. The closed interval alpha to beta. These two results must be in mind in order to solve the problem immediately. That even though in this problem A, B, C, D not true, therefore fourth one none of this is a correct one. Fourth one is the correct answer. I am going for the seventh one. The function f of x cube. F of x cube. F of x equal to x cube. It is the function, already we know that. How the function is, look here. It is an odd function. Even function or an odd function is there. That is f of x equal to x cube. This function is this form, x-axis, y-axis and origin. F of x equal to x cube, the function is now draw this. This function is, the question is a 1, 1, on 2, bijective, none of this. Bijective means it's a both 1, 1 and on 2. I am going for some tricky method. How to find 1, 1? Draw a straight line parallel to x-axis. Draw up until on. Draw a straight line parallel to x-axis. If it cuts the curve at one point, then it is a 1, 1. Already we discussed in the part 1 also. Therefore, I am drawing a straight line AB, which is a parallel to x-axis. It cuts the curve at one point. Then, therefore, it is a 1, 1. F is 1, 1. And also, it is an increasing function. Increasing function from minus infinity to plus infinity. That is, f of minus infinity equal to minus infinity. F of plus infinity equal to plus infinity. And also increasing function. It takes all values from minus infinity to plus infinity in the codomain, which has a corresponding pre-image available. Therefore, it is a both 1, 1 and on 2. F is both 1, 1 and on 2. Then it is for A not correct, B not correct, C is the correct one. C is the correct one. It is a bijective function. It is a 1, 1 on 2. Therefore, it is a bijective function. Look here, f of x equal to x cube. The graph I am drawing, f of x equal to x cube. In order to check it is a 1, 1 on 2, draw a straight line parallel to x-axis, which is a AB. It cuts the curve at one point. Therefore, automatically it is a 1, 1. In order to find on 2, f of minus infinity equal to minus infinity, f of plus infinity equal to infinity. It takes all values from minus infinity to plus infinity. Then the corresponding pre-images are available. Therefore, it is both 1, 1 on 2. The correct answer equal to C. I am going for 8th problem. 8th problem is defined by f of x equal to f of x, which is equal to x minus 1 into x minus 2 into x minus 3. Then, which is a 1, 1. If not 1, 1, on 2, not on 2. We have to check it. 1, 1 condition, you know that. I am checking here, look here, f of 1. If I put 1 here, the value equal to 0. And f of 2, it is also 0. F of 3, it is also 0. Therefore, 1, 2, 3. All the 3 elements goes the same image. Therefore, 1, 2, 3 have the same image, is not 1, 1. This implies f is not 1, 1. Our question, the corresponding answer is 1, 1 or not 1, 1 on 2. Now the not 1, 1 mean automatically f is many 1. F is many 1. That is the correct answer. B is the correct answer. Now I am going for the next one, 9th problem. This is the function from 1, 3, 4 to 1, 2, 5. The set to 1, 3, 4 to set to 1, 2, 5. The function is given. So we draw the diagram set A and set B, which contains 1, 3, 4. And another one, another B set contain 1, 2, 5. The function is defined by 1 goes to 2, 1 goes to 2, 3 goes to 5, and 4 goes to 1. From the diagram, it is clear that the elements are different, corresponding images are also different. In the x is not equal to y from the domain, which implies the corresponding images in the codomain which are also not equal. Therefore, f is 1, 1. In this case, from the diagram, it is clear. At the same time, on 2, if you go for B, the codomain, all the elements, 1 has a pre-image, 2 has pre-image, 5 has pre-image. All the elements have a pre-image. Therefore, f is also onto. This function is both 1, 1 and onto. 1, 1, onto, bijective. So, first one not correct. Second one is not correct. And correct answer equal to C. Bijective is the correct answer. First one, 1, 1. It is a 50% correct. Second one onto, 50% correct. And C is the exact correct answer. I am going for 10th problem. It is defined by, f of x defined by x power 4 plus 1. The power is a 4. It is a even power. Therefore, automatically we can conclude that. And also check the domain. Domain is starts from R to R. Negative numbers available. F of minus 1 equal to minus 1 power 4 plus 1, which is equal to 2. F of 1 equal to 1 power 4 plus 1 equal to 2. Therefore, F is not 1, 1. F is not 1, 1. That is a different elements. Minus 1 is not equal to 1. Is not equal to 1 implies f of x is not equal to f of y. That is, look here, is equal to or not equal to? What is the answer? The answer is equal to. Therefore, f is not 1, 1. That is, the question answer is 1, 1 onto many 1. Bijective also is there. We have to check the onto condition also, we have to check it, but not necessary. Bijective means both 1, 1 onto. Whenever onto failure is D removed and 1, 1 also removed, onto is also removed. That is C only the correct answer. Many 1 is the correct answer. The function is f is many 1. The function is many 1. I am going for the next one, 11th problem. It is given by f from R to R, given by the greatest integer function. It is a very simple one. Look here, the greatest integer function is of the form from here 1 and 2 and 3. This also minus 1, minus 2 and minus 3. I have just to draw the graph for this. Now, draw a this is a greatest integer function. That is y equal to the greatest integer function. If I draw a straight line at x equal to y equal to 1, draw a straight line y equal to 1, it's passing through this. It cuts a curve at so many points. That is, x not equal to y implies f of x equal to f of y. That is, the curve, the straight line cuts the curve at many points, not single point. Here it cuts this much of point, infinite number of points. Therefore, is not 1, 1. F is not 1, 1. Very simple question. Greatest integer function, you know that how to draw it. Look here, from here to the circle, here to the circle. Draw a straight line, y equal to 1. I am drawing it. It crosses the whole graph. That is a many point it cut it. Therefore, it is not 1, 1. 1, 1 failure and many 1 is the correct answer. It is a many 1. F is many 1. This function, greatest integer function, how to draw, you know that. How to draw, you know that. Now draw a graph y equal to 1, which is of the form. Here it cuts the graph at so many points, infinite number of points. At only 1 point only, it is a 1, 1. But many points means it's not 1, 1, many 1. The correct answer equal to C. The next one, 12th problem. F of x equal to 2x plus 1. Already we discussed this type. This is a linear function. The first degree equation, it always represents a straight line. It is an increasing function. Increasing function means automatically it is a 1, 1. It is a linear function. Linear function. Already you know that. Therefore, it is linear function, first degree equation. First degree equation always represents a straight line. It is a 1, 1. It is a result we have it 1, 1. What about onto? That is a f of minus infinity. F of minus infinity equal to infinity. F of plus infinity equal to infinity. Drawing a graph, it is of the form 2x plus 1. Just roughly sketch it. X, y, 0, 1. Put x equal to 0, you get the value 1. Put x equal to 1, you get 3. 0 means here, the point here. And 1 means here, the point equal to 3. Therefore, the straight line, it is of the form, this is equal to y equal to 2x plus 1, increasing straight line, and also minus infinity plus infinity takes all values. Therefore, it is a 1, 1, and also on 2. This is a 1, 1, f is 1, 1, and also on 2. Here, it is a bijective. 1, 1 is a okay, 50%, on 2, 50%, many one failure, none of this also failure. Therefore, among these, it is a suitable one. 1, 1 is a suitable one. That's all. The next one, 13th problem. 13th problem, this is an extension of this. It is a general case of this. F of x equal to ax plus b. It is also linear equation. Just now we discussed the linear equation, first degree equation, always represent a straight line. It is a 1, 1 and also on 2 with respect to the domain. Clearly, f is 1, 1 on 2. Already we discussed well-known result. 1, 1 on 2, many 1. Among these, A is the only correct answer. On 2 is also correct answer. But we are choosing any one. Therefore, A is the correct answer. We are tick it. So, I am going for next one, 14th problem. Find the domain of the function. It is already discussed. F of x equal to square root of x minus 4. Just now we discussed f of x equal to square root of x discussed, and similarly f of x equal to 1 by square root of x also discussed. These two types are discussed. Now this function f of x equal to square root of x minus 4, inside the square root equal to x minus 4, inside the expression always greater than or equal to 4 if it is in the numerator. That is x greater than or equal to 4, the domain of the function equal to closed interval 4 to infinity. 1, 2, 3, 4, that is the correct answer. So already discussed choices are coming here. The next one, 15th, that is a relation from R set 1, 2, 3 is given by the relation R from R to R, from 1 2, 3, it goes to the same 1, 2, 3. The relation is given by what is the relation? The relation is given by set of all ordered pairs 1, 2 and 2, 1, this only. You have to check it is a reflexive, symmetry, transitive. For this, 1 is an element. In order to reflexive, 1, 1 must belongs to the relation R. But 1, 1 not belongs to the R. Therefore, R is not reflexive. R is not reflexive. And what about the symmetry? 1, 2 belongs to this. Automatically, this implies 2, 1 is also belongs to R. 2, 1 also belongs to R. The element 1, 2 belongs to R. The reverse element 2, 1 also belongs to R. Whatever the element exists, that must be reversed. Non-existent, we don't bother about it. Therefore, it is also symmetric. It is symmetric. Short I am writing symmetric. What about the transitivity? Transitivity means, look here. Here the two elements are available. Here the two elements 1, 2 belongs to R and 2, 1 belongs to R. According to transitive relation, 1, 2 and 2, 1, 1 must belongs to R. But 1, 1 not belongs to R. It does not belongs to R. Therefore, R is not transitive. R is not transitive. Therefore, it's not reflexive, not transitive, but symmetry is the only answer. Hence, first one, reflexive failure. Second, symmetry correct. Transitive failure, none of this. That's the B is the correct answer for this. Among the 15 questions, we solved the part 2A, part 1 and part 2. Part 1, we discussed some functions, which is dealing with 1, 1 on 2 and also F inverse, composition of function and relations. relations. Now we are dealing with the same concept of 1-1 onto relations. In this somewhat differ from the previous case also. I am going for next previous problem. In the previous problem, f of x equal to square root of x minus 4. The square root must be greater than or equal to 0. Domain of the function. Just recall it. In this case, inside x greater than 0. In this case, greater than or equal to 0. Here greater than 0. Next, the next problem, 13th problem. It is a linear function. Linear function always 1-1 onto. Therefore, it is a 1-1 onto whatever it may be, take it. Next one, 2x plus 1, the same case of the previous one. It's also 1-1 onto. Whatever you want, you take it. The next one, that is a greatest integer function. If you draw the greatest integer function, at the same time, draw a straight line parallel to x-axis, it cuts the curve more than 1 point. Whenever it cuts more than 1 point, automatically 1-1 failure. And the next one, the x power 4 plus 1, f of minus 1 equal to 2, f of plus 1 equal to 2, minus 1 and 1 has the same element, therefore is not 1-1. That's many 1. The next one, f of x from the function is given by, draw the diagram and check that different elements have the different images. In the codomain, no element left over. All the elements could have the pre-images. Therefore, it is both 1-1 on 2. The next one, 8th problem, f of x given by this function. I am putting x equal to 1, output 0. Putting x equal to 2, output 0. Putting x equal to 3, output 3. Output 0. 1, 2, 3 have the same z element, output 0. F is not 1-1, it is a many 1. And the next one, f of x equal to x cube. Draw the x cube, the curve. It is of the form x cube, it is of the form. Draw a straight line parallel to x-axis. It cuts the curve at the only 1 point. Therefore, is a 1-1. And f of, it is an increasing function also. F of minus infinity, infinity, plus infinity equal to infinity. It takes all values from here to here. That has a pre-images automatically onto. This function is a 1-1 onto. The next one, that is a f of x equal to 1 by x squared minus 4. Find the range of the function. In order to find the range of the function, what I am doing, find the inverse of the function. What is the domain of the inverse of the function? It is equal to range of the function. That we have to find it. The answer equal to, already we discussed. The next one, it is also discussed. The next one, r from equal to log x. Log x function is defined if the argument must be greater than 0. And the domain of the function equal to 0 to infinity. This is from the diagram. And next one, third problem, that is number of functions from A to B is a formula. Order of the codomain, power order of A, 3 power 2, which is equal to 9. It's also okay. Second one, f of x equal to 1 minus 1 by x. That is f of x equal to 1 minus x. And simplification, it is not 1-1 and also not on 2. The next one, the f of x equal to x plus 1 and odd, and f of x equal to x minus 1 even. This function is discussed. It is a bijective function. Some problems are lengthy problem. At the same time, you observe the problem, take the result in mind. The result should be used in the MCQ question. Understand? In this problem, it is a 1-1 onto. Keep in mind, and the answer should be used. Not this, and this only. That is, for the 15 problems are discussed. So far, the part 1, 15 problems, the same concept. Part 1 and part 2, we are somewhat deviating. Day by day, we are deviating from some other ways. So, please subscribe the video and follow it. The next video, let us see that. Thank you.